Hello, good day viewers. This is Tambuwal Academy, still on fractions. Today we want to simplify this numerical expression. We want to simplify 2 whole 1 divided by 3 divided by 2 divided by 3 minus 6 whole 1 divided by 4 multiplied by 2 divided by 3. All divide by 1 divided by 5 multiplied by 1 divided by 3 plus 2 divided by 5 multiplied by 2 divided by 3. And we're going to apply BODMAS in dealing with this problem. BODMAS. B stands for bracket, which is off sign here. O stands for orders, is also off sign here. But division and multiplication, remember, they are done simultaneously, starting with anyone that comes first from left to right. The same thing applied to addition and subtraction. So first of all, I would like to transform this into an improper fraction. 3 multiplied by 2 is 6 plus 1 is 7, so we have 7 here. Divide by that 3. And you can always change this division sign into multiplication, but you have to take the reciprocal of the next term. Instead of 2 divided by 3, we're going to write it as 3 divided by 2. Then we subtract 4 times 6 is 24 plus 1 is 25. Divide by 4. Then you multiply by 2 divided by 3. Then coming to the denominator, since we have only two operations, multiplication, addition, you have to start with multiplication. So let us multiply the 2 times and the 2 times separately before we add their results. 1 times 1, remember, if you are multiplying fractions, multiply the numerator separately and denominator separately. But if you have any common factor between the numerator and denominator, you can always cancel. So 1 times 1 is 1 divided by 5 times 3, which is 15. You add 2 times 2 is 4, divided by 5 times 3 is also 15. Let's go back to the numerator again. You can see that this 3 and this 3 can always cancel because they can go into each other one time. So to the top, we only have 7 times 1, which is what? 7, divided by 1 times 2, which is 2. The minus. Also here, 2 can go into 2 one time. It can go into 4 2 times. Always observe the numerator and denominator if there is any common factor. So to the top, we have 25 times 1, which is 25. To the bottom, we have 2 times 3, which is equal to 6. Divide by. Coming down here, whenever you're adding or subtracting fractions that have equal denominators, you can always add or subtract the numerators. 1 plus 4 is 5. Divide by 15. All right, again, we want to simplify the top first. But this is 2, this is 6. We want a situation where they will have a common denominator, just like this. The LCM between 6 and 2 is 6. Therefore, we are going to transform 2 and 6 into 6. Already, this is 6, so we are going to transform 2 into 6 by multiplying 2 by 3. But for equivalency, we have to multiply the top number by the same value, 3. So 3 times 7 is 21. Divide by 3 times 2 is 6. Then we minus 25 divided by 6. Remember, we have 5 divided by 15. 5 into 5 is 1, right? So we have 1. Divided by 5 into 15 is 3. Let's move to the top and continue. Okay, I think I can manage this space. So if you observe these fractions, they have equal denominators. So you can take 21 and subtract 25. You know, it is going to give us a negative number because 25 is greater than 21. So it's like saying 25 minus 21, which is 4, but you have to attach a negative sign. Negative 4 divided by 6. Don't forget to divide. We can divide this like this by 1 divided by 3. This can be reduced to the lowest term because 2 can go into 4 2 times, negative 2. 2 can go into 6 3 times. Then you divide by 1, divide by 3. Change this to multiplication. So we have negative 2 divided by 3 multiplied by, then you take the reciprocal, it becomes 3 divided by 1. 3 into 3 one time, 3 into 3 one time. So to the top we have negative 2 multiplied by 1. Negative 2 multiplied by 1 is still negative 2. Divide by 1 times 1, which is 1. So you don't have to divide by 1 because dividing by 1 will not change anything. Therefore, the whole of this fraction, if simplified, will result to negative 2. As simple as that. Thank you for watching. Do share to your learning colleagues and don't forget to follow me on YouTube at Tambuwal Academy. Bye-bye.